standing proudly off the coast of Dubai, soaring 321 meters into the desert sky.
The Burj Al Arab is one of the most breathtaking architectural icons ever built. Its brilliant white sail reflects the golden sun, making it appear as if a giant yacht has been frozen above the Persian Gulf.
But this symbol of Dubai's ambition was built in a place where no building should have existed.
If you stood at this exact location in 1994, you would not have seen a hotel, an island, or even a single patch of dry ground. There was no foundation, no bedrock, only open water and loose, shifting sand. Yet just 5 years later, a 70,000-ton engineering masterpiece stood here, rising from the sea. How do you build a billion-dollar megastructure in the middle of the ocean when there is nothing solid beneath it? How do you create land where only waves existed? And how do you protect a structure that could redefine an entire city? This is the untold engineering story behind the Burj Al Arab, a project born from Sheikh Mohammed bin Rashid Al Maktoum's vision to transform Dubai beyond its dependence on oil. He was not simply building another luxury hotel, he wanted a symbol powerful enough to announce Dubai to the world. The challenge was given to British architect Tom Wright from Atkins. His young team had never designed anything close to this scale. Their mission was to create more than a luxury hotel, a landmark the world would recognize instantly. Inspired by Dubai's maritime heritage, Wright found his answer in the elegant sail of a traditional Arabian dhow. His simple sketch became the Burj Al Arab, meaning Tower of the Arabs, a symbol that would redefine Dubai's skyline forever. But turning that vision into reality required engineers to solve the first impossible challenge. Before the hotel could rise, they first had to create the ground beneath it. The artificial island was designed to sit only 7.5 meters above sea level, allowing the building to appear as if it emerged directly from the deep blue water. But the Persian Gulf was far from harmless. During construction, a powerful Shamal storm struck the coastline. 8-meter waves crashed into the unfinished island, threatening to wash away the newly reclaimed land before the building even existed. A traditional seawall made from massive boulders could have protected the island, but it would have destroyed the clean, floating appearance Sheikh Mohammed demanded. Engineers needed a different solution.
They created hollow, perforated concrete armor blocks known as shed blocks.
Instead of stopping waves with solid barriers, these structures allowed water to flow through their chambers, reducing the impact. Like a giant mechanical sponge, they absorbed up to 92% of the ocean's kinetic energy, protecting the artificial island from the Gulf's destructive force. The sea had been pushed back, but the greatest challenge was still waiting below. Deep test borings reaching 180 meters revealed a shocking discovery. There was no solid bedrock beneath the construction site, only dense, water-saturated sand. For a 70,000-ton structure, this created a dangerous problem. Without a strong rock layer, engineers faced the risk of soil liquefaction during a major seismic event, a process where saturated sand can temporarily lose its strength and behave like a liquid. The solution sounded almost impossible. Instead of anchoring the hotel into rock, engineers would make the sand itself support the building. They drove 230 reinforced concrete friction piles deep into the seabed. Each pile extended approximately 45 meters into the compacted sand. The Burj Al Arab does not stand on bedrock. It stands because of friction. The enormous surface contact between the piles and surrounding sand creates enough resistance to support the entire structure. But even after the piles were installed, the battle beneath the surface continued. During basement excavation inside a massive steel cofferdam, thousands of tons of water pressure threatened to force the seabed upward like an underwater cork. Engineers injected liquid cement beneath the foundation, creating a sealed pressure barrier that stabilized the excavation. The artificial island was protected, the foundation was secured, but the engineers had only defeated the sea. Now they had to fight the forces above it. Rising above the Persian Gulf created an entirely new set of challenges. The Burj Al Arab's iconic sail is supported by a massive external steel exoskeleton, a structure that carries the forces generated by wind, temperature changes, and the tower's enormous height. Some diagonal steel trusses stretch up to 85 meters and weigh as much as 165 tons. But Dubai's climate created another invisible enemy. During the intense 50 degrees Celsius summer heat, the steel expands and contracts, causing movement throughout the frame. Traditional welding at these heights would have damaged the clean appearance of the design. Architect Tom Wright wanted the exterior to remain visually perfect. Engineers developed precision, pin and bolt connections that allowed the steel frame to expand, contract, and adapt without creating destructive stresses. But temperature was only one problem.
Wind tunnel testing revealed another hidden danger. The Kerr created vortex shedding, powerful swirling air currents capable of causing dangerous vibrations throughout the tower.
A building this tall cannot simply resist wind. It must move with it. To control these movements, engineers installed 11 5-ton tuned mass dampers inside the structure. These mechanical counterweights absorbed vibrations before they could fatigue the steel frame. The sail shape that made the Burj Al Arab famous was also one of its greatest engineering challenges. A conventional glass or concrete facade could not survive intense sunlight, salt-filled air, and powerful coastal winds. Instead, engineers created a dual-layer fiberglass fabric coated with a special protective material, stretched across the exterior under enormous tension. The material reflected heat during the day, resisted the marine environment, and transformed the building into the glowing white sail recognized worldwide. But creating the exterior was only half the challenge. Inside the tower, engineers had to build an environment unlike any other hotel on Earth. Interior designer Quan Chu transformed the building into an opulent palace, using more than 1,790 square meters of 24-karat gold leaf and rare statuario marble, the same type of marble associated with Michelangelo's David. But luxury created its own engineering problems. Each suite contained advanced electronic systems requiring around 14 kilowatts of electrical power, almost 8 times the consumption of a typical home. This enormous electrical demand created severe harmonic distortion, disrupting the power supply waveform. Left unresolved, it could overheat wiring, damage insulation, and create hidden fire risks. Engineers solved the problem using active anti-phase filters, a technology similar to electrical noise cancellation that neutralized the distortion and protected the building's infrastructure. Even controlling the climate inside the world's tallest atrium presented another challenge. At 180 meters high, the space trapped warm, humid desert air. Cooling too quickly could cause moisture to condense, creating clouds and rain-like conditions inside the hotel. To prevent damage to the gold and marble interiors, the climate system gradually lowered temperatures while removing humidity. When the Burj Al Arab opened, it represented far more than a luxury hotel. It was the result of thousands of engineering decisions made under impossible conditions, a building created where no land existed, an island built where only waves existed, and a foundation supported not by rock, but by friction. The Burj Al Arab proved that engineering could transform impossible ideas into reality. It became a symbol of ambition, the moment Dubai showed the world that construction limits could be rewritten.
Because the greatest engineering achievements are not created by choosing easy locations, but by solving problems that once seemed impossible. The Burj Al Arab was built from the sea, shaped by human imagination, and engineered as a monument to what happens when vision meets innovation.